Hello friends, welcome to Risingpearl.com. Today we are talking about Series 8 where we are learning a lot on arithmetic progression. Now friends, this is webisode number 10. I hope you're following us along at Risingpearl.com. Today we are going to talk about how do we find out sum of the first n number of terms in a given arithmetic progression. So this is the first time friends where we are going to take a look at finding out the sum of a certain number of terms in a arithmetic progression. So at risingpearl.com friends, since we started talking about arithmetic progression from series 1, we have been learning what is an arithmetic progression, what are some of the common terms like first term, second term, common difference, so on and so forth, and then we talked about how do we find out the nth term, right? Before that we looked at what is the general form of writing an arithmetic progression. Then we looked at, I think it was about 5 webisodes dedicated towards solving different types of questions that you may see on arithmetic progressions. I hope you are following us along at risingpearl.com and that you have gone through all those webisodes. So having said that friends, let's take a look at what do we mean by finding out the sum of first n number of terms of an arithmetic progression. So we will begin by saying that let's assume the first term is a and the common difference of an arithmetic progression is d. What is that we are trying to find out? We are trying to find out the sum of first n number of terms. So by that, what is that we mean? So we mean if there is arithmetic progression a1, a2, a3, so on and so forth, right? So a n minus 1, a n. So if this is arithmetic progression, what we are trying to say is we want to find out a1 plus a2 plus a3, then dot 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 plus an minus 1 plus an. So what is n minus 1? Because we are talking about the first n number of terms, so the last one will be an and the one before will be n minus 1, the one before will be n minus 2. So what we want is we want to find out this sum. So if we add all these terms, what is the value? So let us say the value will be s. So our goal is finding out the value of s. So if we have any given arithmetic progression and if we are asked to find out the first sum of first n number of terms, what is going to be the value? What will be the sum? That is what we are trying to find out. So let's do one thing. Let's write a1. So what is a1? That is the first term, that is equal to a. So we know that. What about a2? Well, a2 is nothing but it will be, we can do it in two ways. We can say it's a1 plus d, right? Because we keep adding the common difference to a term to get the next term, right? And then a1 is equal to a, so this will be a plus d. And another way to do that is we can say what about a3? a3 can be, so if we use this formula that nth term is represented as a plus n minus 1 times d, right? So if you put n equal to 3, we will get the third term. So which will be then a plus, right? N will be 3. For the third term, n will be 3. So we will put 3 in place of n minus 1 times d, or this will be a plus 3 minus 1 is 2 times d, right? So similarly, we can find out, so if we do this, so the nth term will be represented by this, right? What about the n minus 1 term? What about this term? So to find this term, instead of putting n equal to 1 to get the first term or n equal to 2 to get the second term, we have to put n equals n minus 1 to get this term. So what we are going to do is we are going to say a n minus 1th term will be equal to, instead of a we are going to replace by n minus 1. So it will be a plus, now instead of n, because we have to write n minus 1, n minus 1, but instead of n we are going to replace by n minus 1. So where we are supposed to write n, we will write n minus 1. And why are we writing n minus 1? Because it is the n minus 1th term that we are looking to find. We are not trying to find out the nth term. So n minus 1 minus 1. What is this minus 1? This is just the regular formula of, the number of term minus 1. So this is that minus 1 times d. So simply if we do this, it will be a plus this will be n minus 2, n minus 2 times d. So what we have done, friends, is that we have just written first few terms. So we have written a1, we have written a2, we have written a3. Similarly, we have written the a n minus 1th term, and this is the a nth term. Now let's do one thing. So if we have to find out the sum, let's do this. So we have s, let's say the sum is equal to s. So s is equal to the first term a plus the second term is a plus d, right? So if this is the first term, this is the second term, and this goes on like this, right? Plus, let's write the first two terms and let's write the last two terms. So n minus 1th term was a plus n minus 2 times d. This is the n minus 1th term, plus nth term is a plus n minus 1 times d, right? So these are, so we have written the first, second, dot dot dot, plus the last term, nth term, and n minus 1th term. Now friends, what we are going to do is we are going to write s equals, now we are going to write the last terms first and the first terms last, because remember, so if s is sum of, let's say, a plus b plus c, we can write this as simply s is equal to c plus b plus a, right? It does not matter when you are adding up the terms, it does not matter the order in which you add them. So why are we doing that? You will see that in a moment. So let's write the last terms first and the first terms last. Again, we are just going to focus on, these four terms. I mean, if we had more space, we can, keep doing this, but let's just for the time being focus on this. So we're going to write the last terms first. So we have a plus n minus 1 times d, which is the last term, nth term, times d, plus the last but one, which is n minus 1th term, that is a plus n minus 2 times d, right? And then plus dot dot dot, we have the second term is a plus d, plus we have the first term, which is a. So why did we do it? So one thing to keep in mind is there are n number of terms, right? So this is the first term, this is the second term, and the last one is the nth term. There are total n number of terms. It's important to keep this in mind. There are total n number of terms, and we are trying to find out the sum of n number of terms, right? So now friends, what we are going to do is we are going to actually add this. We are going to add this. So if we say first one is s equals, this is equation 1, and the second one s equals to the same thing, again just written in a reverse order, and we call that equation 2, we are going to add equation 1, equation 2. And I know it is getting a little bit complicated, but stay with me on this. So s plus s will become twice s. Now you may think, how are we going to really add these two? So we are going to use term by term. So what we are going to do, we are going to take the first term now here, and we are going to add it to this term. So let's do just that. So what we have is a plus a will become 2 times a, right? Because we are going to add the first term with this first term. So a plus a will become twice a, plus we will have n minus 1 times d, right? Because a plus this will be twice a plus n minus 1 times d. Plus now we are going to add the second term with this. So let's do that. So a and a will become twice a again, right? Plus you have d here, right? And if we open this, we will get, let's do this one here. So we will write this as, so this will be n times d. Let's open this up. It will be n times d, minus 2d, right? If we expand, open the bracket for d, it will be n times d minus 2d plus 1d, that will come from here, plus 1d, right? And plus, let's say dot dot dot, and now we will have to add the last two terms. So we will add these two and then we will add this two. So let's add this and this. So let's write it here. So what we have is again a plus a will be 2a plus, so here let's open this up. So it will be nd, it will be nd minus 2d, and here you have plus d, and the very last term, let's add this and this. So a plus a will be 2a again, so twice a plus n minus 1 times d. So we have n minus 1 times d. So now let's try to see what we have. So what we have here is twice s, which is this 2s, equal to, so the first term, so I should actually have written a plus here, right? So the first one is 2a plus n minus 1 times d. So it is 2a plus n minus 1 times d, right? Plus, what about the second term? Let's look at it closely. So we have 2a again, 2a plus, now n times d and minus 2d plus 2d. So minus 2d plus 2d will become minus d, right? So this will be minus n d minus 1. So it will be minus n d minus d, right? So minus n d minus, this will be minus 1, minus 2d minus plus 1 will be minus 1d, right? So it will go like this. Plus, let's try to see what comes out of this. So this will be again 2a plus nd, and then minus 2d plus d again is minus d, right? And then we still have the last term, and this is really 2a plus n minus 1 times d, which is same as this. So let's just write it, whatever little space we have, which is 2a plus within bracket n minus 1 times d. So obviously we need more space. So let's give ourselves more space here. So what we have at this point is we have 2 times s is equal to, the first term is 2a plus n minus 1 times d. The second term that we have, this is d, the second term we have is 2a plus nd minus d plus dot dot dot, third term or the last, second from the last term is 2a plus nd minus 1. I'm just writing this again one more time, plus the last term was 2a plus n minus 1 times d, right? So now if you look at it closely, let's try to simplify this if we can. So 2s is equal to, we cannot really simplify this anymore, so let us just write it the way it is, 2a plus n minus 1 times d plus the second term, we can take d common from between this and this, we can take d common. So we will have 2a plus, if we take d common, we will be left with n minus 1 times d, right? If you look at it, 2a plus, if you take d common, you will have n minus 1. So it will be n minus 1 times d. So plus dot 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 plus, now if you look at second from the last, which is the same as this, so even that can be written as 2a plus n minus 1 times d plus, and the very last term is 2a plus n minus 1 times d. So in other words, friends, all of these terms, they are the same. If you notice, 2a plus n minus 1 times d plus 2a plus n minus 1 times d plus 2a plus n minus 1 times d, and again the same thing. Now how many such terms are there? Remember that we are taking a sum of first n number of terms. So there are n number of these terms. So if you start with, this is the first term, this is the second term, then third term, so on and so forth, and this is the nth term. That means that this sum should be equal to, so, or in other words, what we have is, we have 2 times s is equal to 2a plus n minus 1 times d. And how many of these terms are there? N minus 1, 2a plus n minus 1 times d. There are n such terms times n, because there are n such number of terms in the square bracket. So first, second, third, fourth, this is the nth term. So there are n number of things, which is basically the same as saying, say if you are trying to find out, like say a plus a plus a, if you have 5 of them, right, if you have 5 of them, so that simply becomes 5 times a, right, that is a is 5 times. So we have, instead of a, we have this big term which is occurring n number of times. So this plus this n number of times. So it will be this term times n, the number of times it occurs, right? Just the way we have this term times 5, because it occurs 5 number of times. So in other words, so from here what is interesting is we can say s, we have been always trying to find out s, which is the sum, right? So we can say s is simply equal to, we can bring the n forward, so we can say it's n by 2. This 2 will become denominator, n by 2 times 2a plus n minus 1 times d. So friends, this is the formula to calculate the sum of first n number of terms in a arithmetic progression. Because if you look at it this closely, what is n? N represents the number of terms for which we want to find the sum. A is the first term, n again is the number of terms in the series, and d is the common difference. So this formula, s equals n by 2 times 2a plus n minus 1 times d. This gives us the formula to find out sum of first n number of terms of an arithmetic progression, and that is the reason why we actually added s plus s, and we actually did we initially went with a1, a2, a3 like that, an minus 1 plus an, and then we reversed it to bring the nth term first. So an plus an minus 1 dot 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 plus a2 plus a1. So this is the formula to calculate the sum of first n number of terms in a arithmetic progression. So in other words, so if we have been given a first term, if we know the first term of an arithmetic progression, and if we have been given the common difference, then then the first n number of terms, the sum for that is going to be given by this formula, which is n by 2 times 2a plus n minus 1 times d. So one interesting way to also look at this, or think about this, is that we can think about, let's see if you want to do it over here, which is, what we can say is, so s is equal to n by 2 times twice a plus n minus 1 times d. So this is the formula to find out the sum. We just saw that. One interesting way to look at this is we can actually write this as n by 2. Now instead of twice a, let's write it as a plus a. So why are we doing that? You will just see that in a moment. A plus a, n minus 1 times d, that remains as it is, right? or this equals to, so n by 2, so it is n by 2 times a plus, now what is this term? What is this term? A plus n minus 1 times d. This very term, do you see any similarity? A plus n minus 1 times d? Of course, this is nothing but the nth term. So this is an, that is the nth term, right? And what is a? A is the first term, right? The first term is a, common difference is d. In other words, this is the first term and n is the last term. Remember, we are trying to find out the sum for the first, n number of terms. So our series starts from a1, a2, a3, and it goes till we get an. So in our series, an is the last term, right? And a1 is the first term. So a1 is equals a, right? This is equals a, plus an is the nth term. In other words, even if you don't have the common difference, but somehow if you know the first and the last term of the series, you can find out the sum of first n terms by simply saying it is n by 2, which is the number of the term, times the first term plus the last term. And if you find out this, you will be able to find out the sum of first n number of terms. So friends, in the next few episodes, we are going to take a look at some more questions which involve sum of first n number of terms of a arithmetic progression.